So they've given us two terms that are contained within an arithmetic sequence. Now recall your explicit arithmetic sequence, sometimes called a rule. So this is your explicit arithmetic sequence, where you need to know the first term and the common difference. My 19th term is this, my 32nd term is that. So here's one thing that you can do. Whatever you put there, you put there. Let's plug in 19 both here and here. In like fashion, 32. Plug 32 both there and in there. So you have to fill this out twice, once for each item. So now you have before you a system of equations. A couple of things. I can replace A19 by this. I can replace A32 by that. I know that's 18, I know that's just 31. So now the system looks a little less scary. Now, I want to solve the system and I prefer to use elimination because I see that the A1s are ready to knock out almost. So what I'm going to do is I'm going to multiply the top equation or the bottom, it doesn't matter, by -1. Or I could just subtract the equations however you want. I'm just going to multiply the first equation by -1, all pieces by -1. Now the reason that I did this is because now I have the ability to eliminate the A's, right? They go away. And subtract these, that should be 78 equals 31 minus 18 is 13. 31 minus 18 is 13. Divide by 13. The common difference is actually 6. The common difference is 6. We'll see what that is in a moment. For now, take 6, which is the common difference, and plug it in anywhere into the board to discover the value of A1. I would probably pick one of these two equations. So let's say you took 6 and plugged it in. How about right there? So let's use this green equation here to discover what A1 is. 18 times 6 is 108. Subtracted from that should be -1 equals A1. So my first term is -1. My common difference is 6. We can now fill out our explicit rule with specific values. And that would look like this. And now just by the way, so you can get familiar with the idea of a sequence, my first term was -1. I'll write it down here. My first term is -1. I know that the next piece is going to be 5, and then 11, and then 17, 23, and so on and so forth. You know what? Because my common difference is 6. So to go from one term to the next, I need addition by 6 every time. That's what it means to be arithmetic. Also, you know how else you could have found that 6? This one here? This is a lot like y equals mx plus b, where d is kind of like the slope. Now remember the slope is rise over run, or it's y2 minus y1 over x2 minus x1. You could have found this 6 in a different way. You could have gone y2 minus y1 over x2 minus x1. That's a little bit of a shortcut. There you are, you're welcome. So you could use that method instead to quickly find d if you're ever in a time crunch. But teachers like to see this proper method. So there you are. So that takes care of the first part. They wanted the explicit rule. That is the explicit rule. Now, the next part. You know how I wrote down the first 6 terms. But you know that this goes on forever and ever and ever. And the question here is, if I were to continue this list, like a lot more, would I eventually discover that 221 is on this pattern? Is it on this choo-choo train? Yes or no? If you had 10 minutes, you could write down the next one, right? 47, 53. But who's got time for all that? I don't. So instead, we can do something like this. Take 221 and plug it into a sub n. I have plugged in this here as a value for a sub n. And I want to see if this works. And when I say, does this work? I'll explain in a moment. Add 1 to that. If you want, you can distribute the 6, or you can divide it into 222. These are gone. Now, what's 222 divided by 6? I got back 37. And then you add 1 to this side. So n is 38. So the question is this. Is 221 in this sequence? Is it a member of this family? And the answer is yes. You know how -1 was A1, 5 is A2, 11 was A3, and so on. If you extend this list eventually, you'll discover that 221 is actually the 38th member in this sequence. It is the 38th member of this family. And the reason that my answer is yes to this question, is 221 an element of this sequence? The answer was yes, because of the fact that n was an integer. If n was anything other than like a decimal or something weird like that, then it would have been no. That would not have been a member of this sequence. So it all depends on n being a positive integer. So if they ever ask you something like, hey, is this on that? Then take that number and plug it into a sub n and then solve this equation for n. And if n is an integer, then the answer is yes. And that number would be that place in that family. So it all depends on this being an integer, nothing crazy like a decimal. And it also just has to make sense. These numbers are clearly getting bigger by 6. They're taking steady steps of 6 every time. And I believe that 221 has the possibility of being there because it's relatively larger than those. But again, we rely on facts like this. N has to be an integer. So that's one way of doing problems like this.